Good afternoon, Rotarians and guests. You can always count on Mom trying to sneak in a last-minute photo. Welcome to the Rotary Club of Toledo. I am excited to have a job shadow with me today from Notre Dame Academy. Please welcome Mallory Collin. Of all the people in Toledo she could select, she ended up getting stuck with me. But it's been fun having her along. Yeah. Her mom, Toledo Rotarian, Anna Collin, kindly lies and says she selected me, so I appreciate that. Of course, I'm going to put Mallory on the spot, and so she's going to run the meeting.
That's not fair.
You got this.
That's not fair. Okay. Hi. Okay, this right? Okay. At this time, I'd like to ask Carol Sobchak to come to the podium to deliver a reflection and lead us in the Pledge of Allegiance.
Please stand. In today's meeting, I believe we are going to delve into the world of the very small. But size is relevant, isn't it? Our world, our Earth, seems quite large, but from far out in space, it is but a dot in the distance. As Carl Sagan mused while looking at a picture of our pale blue dot, that's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilizations, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Please join me in our pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Do I get a hug too?
Thank you. Thank you, Carol. As we begin our meeting, I'd like to thank and acknowledge Impact Employment Solutions and this month's meeting sponsor and Rotarian Gary Murphy. Is Gary out there? No, but Kurt is, so we'll give Kurt the round of applause. So thank you very much. All right, if anybody has any guests, we invite you to head to the center of the room. Zach has our microphone there. And again, just as a reminder, in the interest of time, we ask members introduce their guest with name, company, and role only.
Hi, Kevin and fellow Rotarians. My guest today is Wynn Hall with Team Toledo Elementary Athletics Movement. Thank you so much.
Wynn, thanks for being here.
Kevin, I have a special guest, Ryan Morris. Dad is past president of this club, and I'm hoping is a future member. So
awesome. Thanks for being here.
Good afternoon, fellow Rotarians. Today I have the pleasure of introducing my guest today, Dr. Mark Williams, who's the Director of Operations at my school, Explorers Academy. So welcome here.
Excellent. Doctor, thank you for being here.
Hello, everyone. I'm Allison Hammonds, and my guest is John Amato from Juke Mode.
John, welcome.
President Kevin, fellow Rotarians, my guest today is Mike Moore. Mike is a co-founder with the Traumatic Brain Injury Resource Center.
Mike, it's great to see you again.
Hello, everyone. My guest is Haley Studer. She is the founder and CEO of Akai, which is a company that focuses on health, social determinants of health. And if that wasn't enough, she is also the new president of Hospital Council of Northwest Ohio.
Haley, welcome. Congratulations on the new role.
Good afternoon, Rotarians. Nice to see everybody. My guest today is Laura Hoig. She's a part of our ownership over at Adventist Climbing as well as Recycle Works.
Awesome. Laura, thank you for being here. So I don't know how it happened that we were without a mic stand today, but I actually liked it. So I was able to hear everybody pretty well, and when we went through the different height differences, Allison, everybody was able to find their microphone, so that was great. Not calling anybody out in particular, Allison. So, all right. This time, I'll welcome Shanda and Emily, the chairs of our membership committee, to the podium for an important membership committee update.
All right. So I am going to do an adjustment here. Thank you and hello, fellow Rotarians. I am glad to report that we now have 356 members with a number in the pipeline. With your assistance and the great work of Jackie, Karen, and Kevin, the needle is not only moving, but climbing steadily. Since July 1, you have invited more than 65 guests, and you can see today we did that again. Remember, you need to go back to each of those guests and who are not yet members and talk to them about Rotary, please. You are the ambassador for them. Take the next step and provide a link to the application, which is on the website, and make sure to introduce them to Karen. Talk to them about the service projects and the work we are doing and how Rotary can benefit them and others. And so, as we mentioned in the fall, we had our Olympic run. It took off, and I am glad to report it has been completed with a strong finish, which you can tell by the numbers, which ended December 31st. On behalf of the Membership Engagement Committee, we would like to thank each Rotarian for participating and helping us meet and exceed our halfway year goal. Now on to the medal podium. We actually have a tie for silver, and when I call your names, please make your way to the podium. Please help me give a round of applause to the silver medalists. Click. Click. Miss Whitney Keeler and Joshua Dressel. All right. Okay. She did, okay. All right, so what we're gonna do, we have the medal here. These are real medals, so they're not plastic. I didn't get them out of a machine, and they're kind of stuck in here. But here's your medal. Thank you. And we really appreciate it, and all your hard work in doing that, and all the guests and the new Rotarians that are here. So thank you very much. All right.
Yeah, thank you.
Okay. And so now the reveal. For the next, we'd like to say, yeah, that would be helpful. Thank you. Because it got stuck in there. So can you click? Congratulations goes to Miss Julia Hitch. Come on down. Yeah. So I get out.
That's a legit real thing.
It's a real medal. It's a real medal. Yeah.
Yes. Hold on.
Dun, 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 dun. There she goes.
Please stand for the singing of the national anthem.
All right. So thank you so much. I'd like to also personally thank the associates of Mays & Associates who made sure that we had medals and really came in and made sure we had all three. So now, without further ado, my Vice Chair, Emily Zarecki.
Thank you. Just a quick update on the engagement side. Want to let everyone know our next Coffee Connection will be February 7th, starting at 8 a.m., but you don't have to come bright that early, but come on down to Rust Belt. We will be having our monthly coffees at Rust Belt for the next 3 months. We also have a number of fun upcoming events that we've been planning in March, and more to come on this in terms of the details, but we are going to do a not quite happy hour at the Frederick Douglass Community Center. Rotary last year, I believe it was, funded a volleyball equipment for them. So we are going to go there, check it out, and also use it. We're going to play some volleyball, so come join us. More to come on that in the spoke. And also, we are planning an event for opening day. Who wants to come here to the balcony to oversee it all? Come here. More to come on that, but please join us in some of these fun events outside of our Monday meetings.
Thank you, Emily and members. Just a reminder, next Membership Engagement Committee meeting is on February 10th. Onward and upward. Thank you very much.
All right, now if I can invite Julia back up to the stage for a quick presentation. As you all know, it is annual fund season for our foundation, so we wanted to highlight some of the great projects that your club has been involved in, and we're excited to have Julia talk about just one.
First, I'd like to do my acceptance speech for this gold medal. I'd like to thank my parents. No. I am very excited to give an update about the Ann Grady Services Tricycle Grant. So I'm Julia Hage. I'm Director of Mission Advancement with Ann Grady Services. We serve individuals with intellectual disabilities with dignity, respect, and quality services. So back in the summer of 2023, for the first grant cycle through the Disability Services Committee, Ann Grady Services, we applied for a grant for some adaptive tricycles, and I am excited to give you a little peek here. So when we applied, we were granted about just shy of $10,000 with the intention to purchase 2 tricycles. And actually, through a partnership with our vendor, we were able to purchase 4 tricycles. So that is unbelievable, very excited. And you can see just some of the very happy faces here. And actually, our main center, we have this very long hallway that it feels like it's about a half mile long. It probably is close to that. And so it creates a perfect track down and back. And so we have 2 tricycles at our main center. We then have 2 dispersed amongst our day program. So the one, I did capture a little video I wanted to show you all, if it'll advance to the next slide, possibly. So this is Miss Judy, and I want to highlight her.
This is the first time ever you're riding a bike?
So it's the first time ever Miss Judy got to ride a bicycle. She has now passed away, but I think about the opportunity that she had to ride a bike in her 80th year of life and the opportunity of independence that gave her. And so when we're talking about fundraising through for equipment such as the tricycles, it's not just about the physical stamina that they're building, it's not just about the therapy that they get with the tricycles, but individuals actually ask for the opportunity to ride the tricycles, and the therapy team has actually equipped them with horns, and so you can hear them going down the hallway, honk, honk, honking away. So not only did you provide equipment, but you provided happiness, and that, there's no better gift than that. So from Ann Grady Services to you all, we want to thank you for your donation, we want to thank you for your grant, and for the support that you provided to our mission. So thank you so much.
It is also grant season, so I'm going to ask Michelle Klinger to, she's actually going to present from over there. So she's off on the side. But on the screen, she's going to walk you through a process for all of our grants and our committees on how we can approve and review the incoming grants that are due in 4 days.
Yes. So how many of you have our new grant guidelines already memorized? Okay, good. So Toledo Rotary Club has worked really hard the last year or so with the Greater Toledo Community Foundation to rewrite our grant guidelines to make them easier for grantees to fill out the application. And why is this important to all of us? I know Julia just mentioned the work of the committees, and each of the committees review grants to see how we vet them, we talk to the grantees and decide which grants are the ones that we want to pass along to the Foundation Advisory Committee for their consideration. But each and every person sitting in this room who's a Rotarian can be part of this process. If you work or volunteer work at or volunteer for a nonprofit organization, you can help different organizations better understand the grant process by having a little bit of an idea of how it works. So this is gonna be just 2 minutes on how this works. First of all, if you'd like to access the grant guidelines, you can do that 2 ways. At the ToledoRotary.org website /grants, and you'll see, as Kevin mentioned, we have 2 grant cycles, and one of them is ending in 4 days, so get busy, nonprofits, writing Rotary grants. And the second way to access them is through our partners at the Toledo Community Foundation. And there you would go onto their new website, and they have a link for nonprofits, and then grant opportunities for nonprofits. And you'll see down here, if we scroll a little bit, the Toledo Rotary grant. And if you click on it, you can pull up the grant guidelines. And this is what they look like. So it explains to grantees about our committee system and which committee they might want to choose to vet their grant or review their grant based on what their grant is all about. So for you to know what each committee does is really important, because you can help organizations make the right decision about which committee to send their grant to, because the box that they check does make a difference. And then it talks about our grant priorities, and it says who we usually will make grants to. So just so you know, we will not usually make grants to support general operating budgets, to pay for a program that has already been approved through a Toledo Rotary Foundation grant. We don't support grants that pay for lines of credit or capital campaigns, and we don't fund organizational endowments. But we do fund programs, and another important thing is, people ask me all the time, is I just got a Rotary grant last year, can I apply again now? No, you have to wait 2 years from the date on your grant agreement to be able to apply for another Rotary grant. And I looked that up last night to make sure I was right. So this goes through each section of the grant and explains to the grantee how to fill out the grant in the Greater Toledo Community Foundation's portal. It asks them for project description. It asks them for financial information, so they have to have a statement of activities, and they have to have a balance sheet. They have to have some important financial documents to be able to apply for our grants. They have to have a board list. They have to be a 501c3 and have proof with their IRS letter. And it also, this is new to our grant guidelines, it gives them the different qualifications or requirements for grant reports. So that's also an important thing. Many of you might not know, but our grantees have to fill out a report at the end of the grant period, and the Community Foundation now shares that information with us, so we can find out how they did. Beyond checking in ourselves and doing that work, they have to fill out a pretty extensive report of how they spent the money and what the impact was on our community. And then we can have a really good feeling about the grants that we're giving away and how it's making a huge impact on the people around this region. And I want to give you one other piece here. This is where they go. There's a grant, it's called the Grant Portal, and an organization has to actually apply by sending their email address, and they have to create a password. So there is a little bit of a barrier there that people have to have the technological know-how to be able to get in to fill out the application. It's not a paper process. And then you can go in, and there's just a link that says to apply for the application. And just like I just kind of walked you through some things, this asks them the same questions that are on the grant guidelines, asks them to upload some documents. And this is a new feature, the budget. So we asked that the budget would be more fair to all organizations, so that organizations with fancy budgets or brilliant grant writers didn't have an advantage over organizations that don't. So everybody has the same budget line items, and puts the same information in the grant. So every grant budget that you get from now on to vet through the committees is going to look identical, which is pretty nice and pretty cool. And they go in, they upload their files in here, and when they're ready, they click the submit application button, which I'm not going to do yet. And it's as easy as that. But I wanted to familiarize you, all of you, with that in case anybody that you are working with or volunteering for has a question about our grant applications. Pretty simple. But if you have any other questions, please feel free to reach out to me, Michelle Klinger, and I'll be happy to answer any questions you have as well. So thanks, Kevin.
Michelle, thank you so much. Huge thanks to
sorry.
Michelle and what?
One more thing, sorry. On February 10th, I wrote it on my hand, Junior Achievement will be here again. Alec Falkenberg will be the presenter for our 1 o'clock to 2 o'clock session with the JA fifth year students. We are pleading with you actually to stay after if you can from 1 to 2 p.m. and just hang out with the students and be part of that session with Alec Falkenberg. He's going to be, teaching them a lot of really important things about just financial management, wealth management, and good things that young people need to know. Thanks.
Awesome. Thanks, Michelle. Thank you to Michelle, the foundation trustees, and Greater Toledo Community Foundation for all of their work on streamlining and improving that grant process as well. We appreciate it. All right, so I had a mentor when I was a kid tell me that you never want to be the smartest person in the room. And no disrespect to all of you regular Rotarians who attend, but today I've never been more certain that that is the case. As I have said for a couple of weeks, I am not nearly smart enough for today's presentation, but I am very excited for it. Please welcome the CEO and founder of BioSourcia, our speaker today, Ross Youngs.
Terrific, and it's already on. Terrific, so it's a pleasure to be here. I'd like to thank Chris Anderson for inviting me to this, and Kevin and the Rotary Club of Toledo for having me do this presentation. We're going to talk a little bit today about microbiomes. So just have anybody in this room heard of microbiomes and understand every individual has a microbiome? So let's just see hands. How many people know about microbiome? Great. Well, that's perfect because we're going to enlighten you guys dramatically. But let me first start and tell you what BioSource is doing. We're going to the Earth's natural microbiomes, which is a collection of microbes, and we're mining them at an industrial scale. And I'll talk a little bit about that in the future, but I like using the example that if I held up this cup and said, we're going to mine lithium with this cup, how many in this room would think it's the wrong tool, wrong scale, or I'm crazy? Raise your hand, please. Right. All right. Well, we're going to talk about how drug discovery starts with a quantity that's a fraction of this. And our whole approach is let's start with a quantity that has the molecules that are hidden and uncoverable and invisible to science. So we don't start with this quantity, which is a large quantity. We start with about 10 times the size of this room. And that's what we start our drug discovery programs with. But now the real question is, why? Why would we do something like that? And why would we go with those kind of quantities? So let's first talk about the microbes. And it looks like my spacing wasn't exactly right, but that's okay. I'm going to pull this off. So right now, microbes were the first organisms on Earth. About 4 billion years ago, when Earth formed, the first life forms were microbes. Those microbes themselves dominated Earth for more than 3 billion years, meaning it was the biomass on the planet. It terraformed the planet so that we actually went from a methane-dominated toxic chemical mix on Earth to blue sky, clean water, and it was the microbes that really turned all that waste into products that now life uses today. In fact, everyone knows, I believe, and I could be wrong, that wastewater plants use microbes to process the waste and turn that back into clean water and products that can be used or disposed of. So microbes have been incredibly important throughout the history of Earth. And when you talk about the evolution itself, every organism evolved from microbes, and everything that's on the planet today is related to microbes. Let's talk about the human itself. Your human microbiome, which processes virtually everything you consume, is unbelievable. You are outnumbered in cells by your human microbiome to your own human cells, 40 trillion to 30 trillion cells. So you've got more microbes in you and on you than you have your own human cells. Now, I imagine everyone in here has heard of your genomics, your genes. And we know we have 23,000 genes. Anybody ever done the DNA test? It's looking at those 23,000 genes to tell you a little bit of something about yourself. Your human microbiome has more than 25 million genes. You are not only outnumbered in quantity, you're outcalculated by the chemical power of the genetic and the metabolic pathways of your own human microbiome. Now, if you look up human microbiome, if you go home and you go to the internet and you say, what does the human microbiome mean to me? It means everything about your health. And as you look into it a little bit more, you can find out that it is actually responsible for a lot of the ailments that we have. Everything from cancer to neurodegenerative diseases to inflammation to infectious diseases. It's totally connected. Heart disease. You can hardly think of a thing that is not connected to your own human microbiome. Now, why are we talking about this now, and how come this hasn't been known for decades and decades? Well, the reality of it is it took genomics and the ability to look at the genes to even figure out that we had that comprehensive and that impactful of a microbiome in our own bodies, let alone all across the planet. One of the interesting things, I don't know if people have heard of Craig Venter, but he was one of the gentlemen that actually figured out the human genome and sped to figuring out the entire genetics of the human. He ran a project that was called the Terra Ocean Project, and they looked all across the world to figure out what kind of metabolic pathways and genes existed in the microbiomes of other organisms and other habitats. And they found that there's a 73% overlap between the human's genes and metabolic pathways and the ocean's genes and metabolic pathways. So what that really means is it's a resource that we can learn more about a human, because obviously the ocean's in a much larger quantity than an individual human has a particular molecule or species inside of it. And that's really what BioSource has taken advantage of. So one of the other things, and I'm sorry about my type here, it just translated horribly, so I'm sorry about that. But one of the other things I would point out is your microbiomes themselves are virtually involved in production of every kind of food on this planet. So if cows didn't have a microbiome, if we didn't have microbes impacting cheese or dairy, if we didn't have bread, everything, beer, wine, all of these are impacted by microbes and are made partially because of what microbes can do in order to change the composition of something, either reduce it or enhance it in some way. So the first part of this was to help you understand that the microbiome itself is everywhere on this planet and in every human in massive quantities. We all learned years and years ago that microbes were bad and they cause disease and we don't want to have microbes. Well, the reality is no. You want a healthy microbiome because that actually impacts your own health more than anything. So one of the things about these microbes that's quite interesting too is they have the shortest life cycle, average around 15 minutes. So when you have 40 trillion in you, they can turn over in 15 minutes. When you talk about the mutation rate, they have the highest mutation rate of any organisms on the planet, meaning that in that 15 minutes, 1 out of approximately 200 will mutate significantly. Now, I don't know if anybody in this room has heard of the word epigenomics. We have our genomics and then we have our epigenomics. And that is how your own genes change in your lifetime. Believe it or not, every time a microbe dies and it opens up its DNA, there is the chance it can interact with your own DNA and change your human DNA. That's why twins don't maintain the same DNA throughout their lifetime. They actually change. They're born with it, but everything changes, and we all change. And it can create things like cancers and other things that occur within a human. So let's talk a little bit about that calculation power. If you've got so many of them, and you've got such a short life cycle, and you have such a high mutation rate, what does that really mean? We're going to pull up a Harvard presentation here that's 2 minutes long, and I am going to watch my time because I know I need to be careful about that so we have questions. But so far, we're doing well.
So what we ended up building was basically a petri dish, except that it's 2 feet by 4 feet. And the way we set it up is that there are 9 bands, and at the base of each of these bands, we put a normal petri dish thick agar with different amounts of antibiotic. On the outside, then the E. coli can survive, inside there's as much antibiotic, and then across the top of it, pour some thin agar that bacteria can move around in. The background is black because there's ink in it, and the bacteria appear as white. First, you see they spread in the area where there's no antibiotic, up until the point they can no longer survive. Then a mutant appears on the right. It's resistant to the antibiotic, it spreads.
Okay, it may be 2 minutes and 20 seconds long. And I may have to just describe, do the punchline here. Should I just go ahead and talk through it? Okay. So if you could pull the image back up, that'll help me. And then you can freeze it. All right. So what you saw here is there was no antibiotic. There was 1 times antibiotic here. And it defeated that antibiotic that should have killed it because of its mutation rate and its ability to want to continue to survive. At this band, it was 10 times. At this band, it was 100 times. And at this middle band, it was 1,000 times the antibiotic that should kill that microbe. It defeated all of that antibiotic in 11 days. What the point is here is the vast majority of life's chemistry has been created and calculated by the microbes on this planet, whether they're in organisms or they're in habitats. So the vast majority of chemistry that could be interesting to turning things on, off, up, or down in our human body, drugs, have been created by microbes. That's the important part of our theme as a company, is we think microbes and their molecules are categorically the best source for figuring out next generation therapeutics, diagnostics, even agrochemical products. We think it is the source for life that has been untapped. Many other areas have been focused on non-natural products. This would be in the category of natural products. One of the things I will say is, even though there's not this focus on natural products in the entire drug discovery world, there are some people working on it every day. But even without that focus, more than 50% of the drugs on the shelf today have a connection to microbes directly, indirectly, or inspirationally. And that is with science having less than a 1% access to this source. One of the problems is culturing. So we've all heard microbes can grow anywhere. Well, they can't. The reality of it is, I think during COVID, we got told, well, a virus will only live for a couple hours before it dies. Well, that's true of most microbes too. If you don't get them in the right habitat, they won't grow, they won't reproduce, and they won't give you enough quantity to be able to study it. So less than 1% of the microbes on the planet can even grow in culture. But yet, what did grow in culture gave us 50% of the drugs. So when we look at other technologies to obtain drugs, you hear a lot about genomics. You hear a lot about other kinds of what is omics, metabolomics. It's all looking at genes to try to figure out what is going on. This has been going on since really the late 80s, the early 90s, and the reality of it is it has brought us a lot of insights, but it has not brought us cures and treatments. What it's done is the productivity of bringing drugs on the shelf has actually gone down, while the cost have gone up extraordinarily. 84% faster than inflation itself for 40 years. So it really is the combination of productivity decline, even though we are spending billions and billions of dollars a year on trying to find the next generation cures and treatments. Costs are going up, productivity is going on down, and we're still not accessing nature's best molecules to solve some of these problems. I had mentioned earlier the Terra Ocean project and the 73% overlap. Our technologies, when you look at this building, and I said we can process 10 times the size of this building, it is pulling out the microbes from the natural world, whether it be the Maumee River, Lake Erie, whether it be the Gulf of Mexico. Every aquatic environment has microbes, and it's fairly stable. And that's the interesting aspect of it, is typically you'll find 400 to 800 species of microbes that fill a niche or a habitat. And that's a stable producing microbiome, and there's chemistry in there. Now, out of all of history, only 36,500 small molecules or drug-like molecules have ever been discovered from microbes. With one execution of our technology, working with Los Alamos National Lab, we found 73,500 new molecules from microbes. We believe within 3 years of our full-scale execution, we'll take that number from 36,500 to over 1 million novel molecules from microbes and start to truly uncover what's going on chemically in the signaling power of cells. So our technology is pretty straightforward. A couple of these slides are a little in depth, so I'm going to just kind of blow through a couple of them. But we've already talked about why microbiomes matter and why they're the source of what we're doing. Our harvesting technology equipment processes millions of liters of water, taking just the microbes out without harming the microbes, without lysing the cells or breaking the cells, and puts them into preservation right away. Meaning 2 minutes and 14 seconds after it comes out of the habitat, we're already starting preservation. Why? Well, as I explained earlier, they change rapidly, and we want to lock them down for what they're doing in whatever habitat they're at. Now, would I ever be able to get that kind of quantity out of humans? No, that's impossible. The amount of microbiome that has ever been harvested from a human in pretty good, pristine quantity is about a gram. And that is not enough to start understanding what the hidden chemistry is. We obtain 1 million grams dry weight and then start through a processing system in order to break out the chemistry so that we can then screen that chemistry. We have what we call scouting, where we go to sites to see if a particular body of water or aquatic environment is suitable for harvesting. Does it have the kind of chemistry that overlaps the human? Is there the kind of molecules there that have never been discovered? Then we'll go to it and do a large-scale recovery. In the future, our next step is to build the processing facility, because we have the harvesting capability, but the processing facility to take 1 million grams dry weight of a microbiome and extract it, fraction it, build out what's called well plates, and do the analytical work to understand the molecules so we can do AI and machine learning on it. At the kind of scale we're doing it, it's never been done, but we're ready to go and we're ready to do it. In the future, we see large-scale harvesting operations that may even be in conjunction with a water plant. In essence, our kind of processing could be a preliminary processing facility for a water plant, meaning we could remove all the microbes and everything that they don't want to run through their water and wastewater system, which would reduce the cost of running a wastewater system, because essentially we'd be giving them very clean, pre-processed water. And that's one of the approaches. One of our other approaches is, quite frankly, we'd like to put one of these in Chesapeake Bay so we can influence the NIH, the National Science Foundation, DOD, and help them understand that there's a technology to get at what we describe and others have described as the hidden dark matter of biology and microbiology. Yeah. Let me go ahead and finish these slides, and I'll pause. I'll do this really quick. The processing is really straightforward. And one of the things I wanted to mention is I used that example of mining lithium. Well, believe it or not, mining gold is economically viable if they find potentially 4 grams of gold in a ton of rock. They'll grind up that rock and extract that gold, and that's economically viable. We are mining for billion-dollar future molecules, and we believe we will have the capability to find hundreds, if not thousands, of new starting points for next-generation drugs. This is an example of what I mean by the quantity. It's about 8 Olympic-sized swimming pool in quantity. Not much water in reality, not when you talk about a bay or Lake Erie or something like that. When you talk about the kind of molecules we've found with actual collaborators and partners, everything from things that hit cancers to neurodegenerative diseases to inflammation to metabolic diseases. So our approach is to do really great stuff with industrial scale microbiome mining, bringing these molecules forward. And then we don't want to be the developer. I want to work with the biotechnology companies, the pharma companies, the agrochemical companies, and accelerate these new products through their channels. So we want to partner, and that's our major objective. We think we could be one of the largest producers of IP in life sciences within just a few years of execution. I'll pause there and take some questions, or I may stop there.
Check 1, 2, there we are. First off, I'd like to thank you so much. This is such a unique presentation to bring to the Rotary. So first, thank you for that. Second, thank you for allowing me to use my biology degree today, because I like to call my parents and go, hey, I used it today, because I'm not using it otherwise. So when we think about how, it's true though, but that's okay. When we think about how the microbiome within the body is changing rapidly, right? Like you said, every 15 minutes. When we think about biome outside the body and you're trying to extract certain things to create cures for different things or different remedies for different cancers, Alzheimer's, breast cancer, et cetera, how are you maintaining the ability to upkeep with the change of the cells that you would then be treating, or the microbiomes that you would be treating within the body?
So it boils down to what evolution has created as metabolic pathways. The metabolic pathways lead to the chemistry, and it leads to some kind of activity. So for instance, we know an aspirin it actually comes from the root of a tree. It actually impacts pain sensors and numbs them. So the activity is the numbing of pain. The reality is most of the small molecules fall into, let's say, a cascade of activity. Molecules that do things, molecules that are being made to do things, or molecules that are being degraded from actually existing. All of those kind of things are occurring in any life, and it's occurring right now in your body. And even the drugs that we have found, that were found in microbes, they ended up being discovered through screening. So they found molecules through culturing, then they were able to run them through a screen, maybe a cancer screen, or a pain screen, or a weight loss screen, or whatever screen it may have been. They found that chemistry hit that screen. So that's been the traditional approach to drug discovery. It is now rapidly moving to data sets, AI, ML, to do a lot of that screening. And that's one of the things that we're incorporating into what we do as well. So the molecules in nature all have a reason. There's a limited number of those molecules in nature. It's not infinite by any means, because think about it this way. Metabolic pathways that exist in plants for handling sugar are exactly the same pathways that exist in us. The reality, biology has retained what works through all the species. So we can find those kind of molecules using other sources that will relate to the human therapeutics. Hope that helped.
So thank you. This is really fascinating. I am envious of a biology degree. My history degree helps me with bar trivia, but not this. I'm curious about the business model. So your business model, you mentioned mining gold, and this is mining molecules. Is there, from an IP perspective, do you then own a molecule you discover? What is the business model behind your discoveries, other than finding it and then letting people know they exist?
No, that's a brilliant question. So it's multifaceted, but the big game-changing aspect of it is us finding a molecule, particularly in nature, which is unpatentable. But if you learn its activity, then you have advanced an unpatentable molecule to a patentable opportunity. So if you find a novel molecule that actually does something, that's patentable. Then what happens in chemistry? If anybody's ever heard the word med chem, medical chemistry, is they'll modify molecules they'll find. It's called derivatization. And they'll try to improve it or optimize it for working in the human. It's no longer a natural molecule if you do a little change to it. It's now something that's patentable, not only for its molecule itself, but its activity. So the vast majority of what we will be doing will be creating IP, ultimately working with those partners, and in many cases, collaborators. So it's a multifaceted model. But when we work with a partner, let's say pharma comes to us and says, we want you to find 5 molecules that hit this weight loss target. They would sign up, pay us upfront, milestones and royalties, so lower risk with the upfronts. Although I will tell you, discovery deal upfronts recently with quality companies that are highly respected have been between $100 and $150 million for a small set of potential molecules. So that's one of the ways. Working with universities, we also have the model where we will collaborate, and we have signed up Stanford, Harvard, Ohio State, University of Michigan, Case Western, and many others who will high throughput screen our molecules looking for hits against targets that a principal researcher may have an interest in. Then we're in a position where we can work with that professor or that researcher and advance that molecule that may be turned into a new company and funded ultimately through various channels, but BioSourcer will be connected to that via licensing and potentially a piece of the ownership of the company. The other thing that happens is when you go to an aquatic environment, there are lots and lots of known rare molecules. We obtain them at such a depth that we will be able to provide those known rare, nearly unobtainable molecules through research channels and be able to sell those as well. And then the data side. We're on the situation where all the universities we work with feeds us back data. We fed them our molecules, all proprietary. We end up finding out what those molecules hit. We build the best data set on novel molecules that we possess. That means other pharma companies or biotech companies, even if they're doing drug discovery via AI, could come to us and our data sets, which would be the best in the world, and be able to work with us to advance their purposes and their needs. I hope that helps on the model. Last question.
Does your technology have any applications outside of human medicine? For example, things like habitat restoration in an era of climate change, or repairing wetlands or polluted lake waters, things of that sort?
I would say there is a difference between our technology and the purpose that you had mentioned. So when we started what we were doing, we were focused on utilizing algae or the microbiomes of the aquatic environments, that biomass, to potentially move it into energy or plastics or other products. And we had created a technology, ended up getting patents on it. We call it our generation #1 technology that was highly efficient. And it was the reason the DOE gave us $6 million to advance that technology. We were able to prove we could pull microbes out of the water at a fraction of the cost that it was done historically. Typically, the best case situation for doing it was around $3,500 per ton, and our technology brought the cost down to $1.98 per ton. But it wasn't suitable for drug discovery. It was partially suitable for drug discovery. And ultimately, we advanced that technology. And when you think about improving, let's say, the capability of a system, you've probably got to put more dollars into it, more energy into it to reach that 100% threshold of a recovery of a microbiome. So our earliest technology the ones we have patents on that were created a little more than a decade ago, those could be very useful in the future for doing exactly what you're talking about. The challenge is there's no real money in that. That's the challenge. But we do have a vision where water ultimately will be able to be used through low energy harvesting of biomass systems that could have impact on communities and places. And I know I got to end this thing right now, but I will tell you a story. We presented in Abu Dhabi, and I had a minister of an African country come up to me that was located on Lake Victoria at the time. And there are 3 countries that are on Lake Victoria, and it is one of the most polluted lakes in the world, and there's 90 million people depending upon it. But the water makes Grand Lake St. Mary's look clean. The reality of it is the need worldwide, the need even here in the U.S. for clean water and handling the growth of organisms that are taking advantage of the nutrients that are in there. There should be an approach that could handle that someday in the future, and we're all for that. It just needs to have a viable business model. Thank you.
Appreciate it. Ross, thank you so much for your presentation. We've got 2 gifts for you as a thank you for the time with us today. First and foremost, we are going to make a donation in your name to Rotary International's Polio Plus Fund to join with Rotary International's efforts to eradicate polio. Secondly, I've got a book for you I'll give you afterwards that was authored by our past president, Clint Mock, called Historical Tales of Toledo. Thank you so much. One more round of applause for Ross Youngs. I hear these presentations and business ideas and the wheels start spinning and I'm like, oh, I wonder if I could do that. And the answer is overwhelmingly no. I could not do that. A reminder, tomorrow's new member orientation is at 5:30 at Shoemaker. Please park in the rear of the building, enter through the back door. Part of the beauty of having so many new members is we're probably going to have to start doing this a little bit more regularly, but we're excited to have, I think it's over 50 attendees tomorrow for our new member orientation. So looking forward to that. We've got some great programs this February. Next week, Frank LaRose, Secretary of State of Ohio, is going to be here on February 3rd. Father O is going to be, we're taking him out of retirement, and he is going to be leading next Monday's meeting. So we're excited to bring him back into the president's seat for that. February 10th, we'll be having a panel discussion on lifting Black voices in celebration of Black History Month. No meeting on February 17th, and we'll return on February 24th with a panel discussion on rare disease with Deb Ayers, our own Toledo Rotarian, Deb Ayers, who is here somewhere. Okay, she's not here. I just called her out for it. That's what you get for leaving early. I'm going to call you out. But Deb Ayers at the Avalon Foundation will be leading that conversation on rare disease. One committee meeting. Program is meeting in Jefferson C. And again, if you're not currently on a service committee, we recommend you do that. International services met before this meeting, and so we'd love to have you guys involved in that. So thank you again for being here. Go out and make it a great day. And we are, what? Oh, I'm sorry. Hang on. Mallory is going to adjourn us, and then I guess she's going to ring the bell. Come on up. All right, so there it is. That's your line.
That's my line. How do I ring it?
You hit that thing.
Okay. We are adjourned. That was fun. Yeah, that is fun.